Hola, hi, this is Al Nozal, your probability and statistics instructor. Time to start doing probability. Let's begin. Okay, in this short video, what I would like to do is using an example to illustrate and discuss a couple of important concepts in our course. Those concepts are A. Discrete random variable, and B. Probability distributions. Okay, so here goes our example. By the way, this example can be found in our lecture notes. Okay, but let me just write down some of the details so we can solve that problem together. So we have a couple who plans to have 3 children. So if that is going to be our random experiment, there are 8 possible outcomes. Note that there are 8 possible outcomes for this random experiment. For instance, GGB is one of those possible outcomes, right? And what that sequence means is that the first child was a girl, the second child was a girl also, and the third one was a boy. Now, these 8 arrangements are going to be assumed to be equally likely, and we are also ruling out the possibility that this couple could have twins, for instance. Okay? So the questions that we would like to answer are these. We want to write down all 8 arrangements of the sexes of these 3 children. We are going to define a variable x that represents the number of girls the couple has, and we would like to find the probability of x being equal to 2. Finally, we want to find the distribution or probability distribution of x. Make sense? Okay, so that's our problem. So at the beginning I said that we were going to use this example to talk about a couple of concepts, right? And maybe you recall that I mentioned a discrete random variable. But before we talk about a discrete random variable, let's try and recall what a random variable is. So maybe you remember that at the end of chapter 2, the concept of random variable was mentioned. So a random variable is a real valued function for which the domain is a sample space. Or, in other words, a random variable assigns a real number to each outcome in the sample space. Make sense? So, for instance, here the result of this random experiment is a sequence, right? GGB is one of the possibilities, one possible outcome for this random experiment. Another one would be GBB, for instance. Okay? But those are just sequences, right? Are elements of a sample space. And since we are interested in the number of girls, right? Let me fix this here. I had a typo, girls, that's better. Then we are turning those, we are assigning to those elements in the sample space, to each of those 8 sequences, a number. Okay? So that's a random variable. Again, what we're doing is we're assigning a real number to each outcome in the sample space. So let's begin with that. Let's write down those arrangements, those sequences. We were saying, for instance, GGB would be one of them, right? But let's write down all of them. Okay, here we go. One possibility. Let me use that notation S. Remember that we use a capital S to represent the sample space. So G is one possible outcome. Another one would be B. Another one B. Another one B. So we have 4. How about B, G, B, G, B. Do you agree that those are the 8 possible sequences, the 8 possible outcomes for this random experiment given our assumptions? Make sense? Something else that you could do to come up with this sample space. Recall, let me change this here. Okay, recall that you could do this using a tree diagram. Remember those counting techniques that we discussed back in chapter 2? So we know that that would be a nice, easy way of finding these 8 possible sequences. Okay, So we're done with the first part. We have the sample space. So now X represents the number of girls the couple has. And once we have defined that event, because remember that an event is a subset of the sample space, and in a minute we're going to see how that event is formed. Once we have those guys, we are going to find the probability of X being equal to 2, meaning that this particular couple has 2 girls. Okay? So we are going to write down the event X equals 2 in terms of the original sequences. Okay? So in that case, that would be the same as finding the probability of observing the following sequences: G, G, and B, or G, B, and G. So we again have 2 girls and 1 boy. Or last one would be the first one was a boy and the last 2 were girls. Now, using the properties of a probability function, we have the probability of union, right? That's the OR. Since these events are mutually exclusive, the probability of that union is equal to the sum of those probabilities. Probability for each of those sequences, right? So we have G, B, G. Sorry, there we are. And last one, B, G, G. Let me just remind you. Events. Well, yeah, we know that a sample point, one of those sequences, is an event, a simple event. Okay, so we have mutually exclusive events. That's why we could do what we did. Okay. Now, the probability for each of these sequences, that's what we need, right? And what we said is one of the assumptions is that each of these sequences has the same probability, that they are equally likely. So we have 1 over 8 plus 1 over 8 plus 1 over 8, 3 over 8. Makes sense? So that would be part 2. Okay? Now, here comes the second concept that we said from the start that we were going to be discussing. the concept of a probability distribution. Okay, so what's a probability distribution? Well, in this case we have to be a little bit more specific, because we are going to be dealing in the future with different random variables. We're going to be dealing with continuous random variables as well, and also in the near future we are going to be talking about discrete random variables. So first, what's a discrete random variable? A discrete random variable is a random variable that can assume finitely many outcomes or a countably infinite number of outcomes. And just let me remind you that a countable set is an infinite set that has a one-to-one correspondence with the positive integers. Okay? Okay. So, anyway, what I would like to underline here is that this guy, x, the number of girls the couple has, is an example of a discrete random variable, because it has finitely many it has a finite number of outcomes. Okay, so a probability distribution, a discrete probability distribution, is nothing more than the list of possible outcomes for x with their corresponding probabilities. Okay, so here we go. The probability distribution, as we said, is a list of possible outcomes with their corresponding probabilities. So x could assume the value 0. Maybe they have no girls. Or x could be 1. Or x could be 2. Or x could be 3. By the way, notation, we're going to be using a capital X, Y, or W sometimes to refer to random variables. Okay, so let's do what we did before, right? The probability that x equals 0 is the same as the probability of an outcome in the original, in terms of the original sample space, if you will. Okay, so in terms of the outcomes of the experiment, x equals 0, meaning they have no girls, only if they observe that sequence, boy, boy, and boy, right? And what we said is we're assuming that the probability for each of these possible sequences is 1/8. X equals 1. In that case, what we have, it would be the probability of having just one girl. So it could be something like this. The first one is a girl, the last two children are boys, or first one is a boy, second child is a girl, and last one is a boy. Finally, we need the probability of the first two children being boys and the last one being a girl. These each of these sequences is equally likely, so 3/8. This one we got from the previous part, 3/8, right? Last one, probability of x being equal to 3 would be the same as probability of girl, and that's only one out of those 8 sequences. Make sense? Okay. So, let's summarize what we did. One, we talked about the concept of a random variable. And what we said is a random variable assigns a real number to each outcome in the sample space. Let's write that down. A random variable assigns a real number to each outcome in the sample space, just like what we did here. Okay, we had 8 sequences, and then this random variable had a correspondence between the outcomes in the sample space and these numerical values. Okay? Another thing that we said is that we talked about the probability distribution of a discrete random variable. So just let me remind you that probability distribution of a discrete random variable is a list of the possible values of possible values of random variable and their probabilities. Okay? And finally, let me remind you that a discrete random variable assumes only a finite number or a countably infinite number of outcomes. Okay? Okay, so that's it for now. Take care and keep working hard. See you next time. Bye.